So we are doing that outer measure of an interval is its length. So we are seeing the case 1 for closed interval, finite closed interval. Now let us see case 2. So case 2, we assume that I is an arbitrary finite interval. So it can be open or semi-open. So let us again show that in this case m star of I will be equal to length of I. Now നമുക്ക് തന്നിരിക്കുന്ന ഒരു ഓപ്പൺ ഇന്റർവൽ ആണ് അല്ലെങ്കിൽ സെമി ഓപ്പൺ ഇന്റർവൽ ആണ്. So the interval is I. So let me consider an open interval I. Given an open interval, we can always find a closed interval J inside this, okay? Such that the length of J is sufficiently closer to the length of the interval I. So given a finite interval I shown in the figure, we can find there exists a closed interval J such that J is contained in I, such that J is contained in I and the length of J is sufficiently close to the length of I. So, since the length of J is sufficiently close to the length of I, so there exists a closed interval J contained in I such that, so you can find an epsilon greater than 0 such that length of I minus epsilon into that will be less than length of J. So you can find an epsilon such that length of I minus epsilon is less than length of J since the length of I and J are sufficiently close to each other. And now as we know J is a closed interval, since J is a closed interval by case 1 closed interval ആണെങ്കിൽ finite closed interval ആയിരുന്ന കേസിൽ L of J എന്ന് പറയുന്നത് that will be equal to the outer measure of J. So L of J will be equal to n star of J. So putting this equal to n star of J, we will be getting L of I minus epsilon is less than n star of J. Again, since J is contained in I, again we are seeing for sets, if J is subset of I, then n star of J will be less than or equal to n star of I. So therefore, again the inequality I can write it as L of I minus epsilon less than n star J. So that will be less than or equal to n star I. And okay, so we will get the inequality in this form. We know that for any interval I, so I will be contained in its closure. So the closure is set together with its limit points. So I will be a subset of I closure. So since I is subset of I closure, again by the property of outer measure, n star of I will be less than or equal to, so n star of I will be less than or equal to n star of I closure. Now നമ്മൾ ഇവിടെ നമ്മൾ I എടുത്തിരിക്കുന്ന ഒന്നെങ്കിൽ ഓപ്പൺ സെറ്റ് അല്ലെങ്കിൽ സെമി open set. So these are the form of the intervals we have. Now for this interval, so if you take the open interval AB, അതിന്റെ ക്ലോഷർ എന്ന് പറയുന്നത് ക്ലോസ്ഡ് ഇന്റർവൽ AB ആണ്. ഇവിടെയും ക്ലോഷർ നമുക്ക് ക്ലോസ്ഡ് ഇന്റർവൽ AB കിട്ടും. And for this also the closure will be closed interval AB. So when you take I, so you get m star of I closure. So I closure will be a closed set. So that will be equal to length of I closure. Okay. So again we can write down the inequality in this form. ഇനി ഇവിടുന്ന് length of I closure will be equal to length of I as you have seen for these two sets. Open interval ആണെങ്കിലും length b minus a ആണ്, അതുപോലെ closed interval ആണെങ്കിലും length b minus a. So our inequality can be extended in this form. So we get L minus epsilon less than L of j. So that will be equal to L of j എന്ന് പറയുന്ന ക്ലോസ് സെറ്റ് ആയതുകൊണ്ട് m star of j ആയിരിക്കും. That will be less than or equal to m star of I. So that is less than or equal to m star of I closure. So which is finally equal to length of I closure. So that is again equal to length of I. So we can ഇനി ഇവിടുന്ന് ഇതിന് inequality എന്ന് പറഞ്ഞാൽ length of I will be less than length of I plus epsilon നമുക്ക് എഴുതാം. So this inequality would give me L of I minus epsilon less than m star of I less than L of I plus epsilon. So that would give modulus of m star of I minus L of I is less than epsilon. Now the choice of epsilon can be made as small as possible. So that means this difference will be can be any small positive number. So this happens only with this positive number less than epsilon around. So that can happen only if m star of I minus L of I is equal to 0. So that would give m star of I is equal to L of I. So that gives the required result. So since epsilon can be made sufficiently small, so modulus of m star of I minus L of I is a fixed non-negative number which can be made less than any positive. It can be made less than any small positive. So therefore modulus of m star of, so this is possibly modulus of m star of I minus L of I is equal to 0. So that would give m star of I equal to length of I. So we will get the required result. So when I is an open or semi-open interval, then the outer measure of I will be equal to its length. Now let us look at case 3. In case 3, we will take I to be an infinite interval. So suppose I be an infinite interval. Now if you are given any delta greater than 0, then we can always find, so we can find delta greater than 0. നമ്മുടെ ഏതെങ്കിലും ഒരു ഫൈനൈറ്റ് പാർട്ടിക്കലാണ്. So we can find closed interval J, which is contained in I, such that length of J is equal to delta. So, if I is an infinite interval, so we can, for any delta greater than 0, you can find a closed interval J, which is contained in I, such that length of J will be equal to delta. Now, since J is contained in I, so length of J would be less than length of I. So that will give M star of system equality. Length of J will be less than I. So M star of J will be less than or equal to M star of I. So that implies you will have delta less than or equal to M star of I. So you will have M star of I greater than or equal to delta. Now, delta can be made any large as possible. So, delta can be sufficiently large. So, therefore, M star of I must be infinite. So, being an infinite interval, നമ്മൾ infinite interval case we have defined length of an interval to be infinity. So here we are getting M star of I equal to infinity. So that is again equal to length of I. So that will give again M star of I equal to length of I, which is our required result. So when I is an infinite interval, so we are getting M star of I equal to length of I. So this completes our proof. So therefore, whatever is the type of interval, so whether you have a finite interval or infinite interval, whether it is closed, open or semi-open, then its outer measure will be always equal to